So, main focus of this last part of our cycle has been lots of area, lots of perimeter, lots of things with shapes, and figuring out different pieces of the puzzle. And so that's basically what this is going to look like too. And I couldn't find anything that I liked that looked better, so I went into hearty creative mode here, as you can probably tell. So when you've got all this stuff with area, again, in our notes, kind of might want to get used to it as we go here. We got everything that we're going to need with samples and formulas and stuff in our packet. So we're going to reference this a lot. So area of the figures, biggest thing you're going to have to watch out for, because I am occasionally going to throw in some numbers you might or might not need just to see if you're on top of things. So, for instance, I look at this first one and I'm like, all right, looks like a parallelogram. Even with Hardy's drawing, that looks like a parallelogram. And so with a parallelogram, I need base times height, but I got 3 numbers. So here's the question. Which 2 of those 3 numbers am I going to be using? Yep. I'm with you. So here, even if I wasn't sure, and that's absolutely right, I can look here and say, hey, it looks like the dotted line is my height, and then my B is whatever that's connecting to, which would be the 16 in this case. And when we're doing these, one critical thing that I'm going to be looking at that's going to be worth a point on each question is labels of stuff. If it's area, we've got to have feet. We've got to have squared, especially. If it's perimeter or if it's circumference, I still got to have my measurement, but we don't have the squared with things. So a few things just to keep track of as we're going through. And I'm trying to just think of some spots. Okay, let's move down a little. I'm going to go past 2, at least for the moment. So 3, what shape is 3? Trapezoid, I'm with you. So if I pull that out, I'm like, okay, so now I need 3 values. I need base 1, I need base 2, and I need the height, which again means one of my numbers is going to get left out. Unfortunate, but true. So I'm just going to write my formulas when I'm doing these. Just in case you're looking later and you're like, okay, where's he getting that from? Okay, here's our formula. So where are my numbers going to plug in? I'll supply the 2. Okay, 12 and 8 are my bases. And 4 is my height. So when I'm rolling this one out, if I'm going to try and put it all in at once, I got to do one little different thing. Actually, let me grab a calculator myself here. I'm going to wait till I get back up through it. It's going to be so loud, so you're going to think, I've gone deaf and can't hear anything. It's partially true. Okay, so I look and I go, okay. So I would be lucky enough that if I just typed all that in directly this time, the order of operations isn't going to mess with me. But I am still a fan of doing this a piece at a time, just because that way if there is an order of operations issue, it's not going to burn me and cause me a problem. Okay. This one, I don't want to do the whole thing. I just want to do a piece because we have multiple shapes here, and neither of them is a bad one. We got length times width. We got our rectangle over here. Here we got a square. So my area is just side squared. Length times width, I'm like, I'm good over there. I'm good. Ooh. No sides given. How do I figure out how long the missing side is?
40 minus 18?
Perfect. Okay. if I take the full length of my shape and I say, hey, I'm looking up here at this 18. I'm just going to do a little mark off here for a second. So that much is 18. That doesn't take care of that whole length. There's still this little piece left. So 30 minus 18 will get me that other side. And now I've got what I need to find the area of the big one. And I've got what I need to find the area of my square. And I can just add them together. So sometimes you may have to do a little sleuthing here. You may have to work through that a little. But hey, we can survive that and get that done. So that's one of the things I want you thinking about as you're doing this. You've got to pay attention if it's area or perimeter. So, let's see here. Find the perimeter, which is the outside. So I need to know what's going on here. So you're noticing a pattern starting to develop with me here. I'm trying to throw weird numbers in on every one. Sometimes they're helpful. Sometimes they're there just to mess with you. I'll be honest. So I look and I'm like, okay, so I don't know. Let's start with the easy one. What's this side going to be? 24, because it's the opposite side of a rectangle. So we got that one knocked out. These will be the same, but I don't have either one. So how would I find one of these? It would, because the whole thing is 17 and that piece is 7. Yep, which means those are both going to be 10, and now I have all the pieces I need. Don't need the 24 though, because that's inside and the perimeter is outside. So we can it was helpful to get me this, but for that itself, I definitely don't want it. And 6 is just completely me trying to mess with you and trick you. You actually have all the info there that you need already. So let's see, perimeter. So wait a minute. Hardy says you've got all the info you need already, but I only see those 3 numbers. Why would I be saying you got all the info already? What's that? Oh, let me get. I've run over here. Oh, that's okay. I wasn't specific either. I wasn't specific either. That was me. And that's true. So here, what are my other 2 mystery sides that I don't know yet going to be? So yeah, with these, when you have a parallelogram, your opposite sides are always congruent or equal. And so here, that lets me just play the game with this. Well, Hardy, what about the 3? Is that on the outside? No. The dotted lines are just here to say, hey, if I extended it, that's how I could get the height. That's not part of the actual shape, though. So the 3 was just there, again, trying to mess with you on this. But do remember, when we get to the end, yes, it's good to get all the values, but to find the perimeter, we actually have to add them all up. So make sure you don't forget to add them all up. That wouldn't be good. And to get your label, and again, perimeter is just going to be the label, not squared. That's only when we play with area. So you can kind of start to see it's going to be straightforward with the formulas, but we're also going to have to be a little bit cautious with how some of these are running. So when I flip over to the next page, I'm like, okay, area and circumference. I flip to the next page of my notes. And so I got to find both for these, not just one. And so I do a little bit of research here, and I'm like, all right, area is pi r squared. Now, circumference, it depends. It can be pi times diameter. It can be 2 pi r, depending on what we're doing. So I'm going to jump in on number 8 because it has a little bit of a twist. Make sure we're feeling all right. So I look and I'm like, okay, well, circumference, that's easy. That's just pi times diameter. So 16 pi, I don't care if you leave it as 16 pi inches. I mean, no, somebody's not going to go up to somebody, hey, how far is it around that circle? 16 pi? Probably not. But again, if you want to be specific, your button presses would be second, and our caret, our up arrow. So if we wanted to be like 50.3, even if you don't remember the pi part, and just said, hey, 16 times 3.14, that basically is going to get you to the same area. I mean, if you rounded, you say 50.2, but I'm going to understand where you were heading with that. But again, labels, very important. But, okay, area, pi r squared. I'm like, okay, so pi, oh, that's not a radius. How do I get a radius out of that? Divide by 2. So either side of my radius here is going to be 8 inches. And again, it's pi r squared. So 8 times 8 or 8. This x squared button will always get you squared on these, or you can use the caret and 2. And second up arrow. Ooh, that's kind of chunky. Again, here, I'll talk about that in a sec. Hang on. I'm getting ahead of myself. If you're going to leave it with pi, I do want you to at least multiply out the 8 squared. I want to make sure that we get 8 squared is 64 and not 16. So 64 pi square inches, 201 square inches. I'm cool with either. We just got to make sure that we get that set. Okay. One question without a picture, but I think we're going to be, ooh, let's hang here for a minute. If the circumference of a circle is 48 centimeters, find the radius. You're like, okay, wait. The circumference is all the way around. That's not just like the diameter or the radius. So let's think about this. So we want to find the radius. So when it's circumference and we have radius, we use 2 pi r. And the circumference is 48. We want to find the radius. Ooh, we're going to play a little algebra game here. So we're multiplying this 2 and this pi times the radius. How do you undo multiply? Divide. Now, here's where this gets a little more interesting. All right, let's see what we got here. This is the one where if we're going to put it directly in our calculator, we need to put parentheses around the 2 pi, and I'll show you why. So here's the answer we actually want. So we'll call it 7.6 here. If I don't put the parentheses in, that's a little bit of a difference. Now, I would hope if you saw this and you got that answer, you'd be like, wait a minute, Hardy. The circumference is 48 and the radius is 75? That makes no sense. And you'd either be like, wait, what's going on with my calculator, or what went wrong here? So that's why I'm going to try and stress the parentheses so we don't have that issue if it comes up. Maybe, possibly, probably, tomorrow. But just little things can make a big difference. Oh, I can tell I was hungry when I was thinking about that, even though my donut looks like an eyeball more than it does a donut. So Mr. H making a giant donut. The radius of the donut is 3 feet. That'd be awesome. The width of the dough is 2 feet. Find the area of the finished donut. Okay. So we've got this outer circle. Let me do some color action here. So here's if we didn't have a hole in the donut. So my outer circle, we're looking for area. So I'm like, okay. So I've got my radius here. And area, that formula doesn't change. So my area is pi r squared. So let's see here. Second that times r squared. So we'll call this 28.3 cubic feet. Gosh, that sounds up. That's a donut right there. Okay. Gotta get my focus.
Square feet, not cubic.
Square feet. Did I say cubic?
Yeah.
Oh dear. I wrote the right thing and said the wrong thing. That's interesting. So yeah, definitely square. Ooh, I'm trying to make this really big. Ooh, okay. So I come back and I go, okay. So my inner circle. That's a little more interesting. What's the radius of my inside circle? Nice. How'd you get that? Absolutely. If it's 3 all the way from the center to the outside, and the dough part out here is 2, that leaves me 1 foot left in here. So we'll play this one more time here. Should just be 3.14, but we're going to make sure because it is Monday morning, and hey, we know what that means. Okay. So 3.14, you could round me to 3.1 or 3.2, and I'm not going to be... I'll make it 3.1 because that's going to make more donut. And then we're just going to subtract them. So that's a lot of donut. I've had some large donuts in my lifetime, but I don't think I've never had one that big. Good project for the future. Good project for the future. That's awesome stuff. All right, I got to stay focused here. We're not going to get through here. All right. Find the area of the shaded region. This really just comes back to the areas we've already talked about. We just have to make sure that as we're doing these, we'll do a couple here, that we're being careful of what it is we've got. So here, let's see. My outside is a circle. My inside is a triangle. So what I'm going to do is I'm going to find the areas of each, and I'm just going to subtract them from each other. So the donut question was kind of a preview of what we're doing here. So my circle, okay, pi r squared. So pi, what's my radius this time? 2.5, center to the outside. So there's my radius. All right, I got that one. I got that set up and ready to go. Then my triangle is either 1/2 base times height or base times height divided by 2. What's my base and my height this time? My base is 3 and my height is 4. And again, showing that stuff helps me because then if somehow, which I do plenty often myself, if we do a bonehead at some point, at least I can see, hey, we knew what the form was. We just had a little bit of a calculator punching it in issue. Oh, good job, Hardy. No labels on number 11. We're just going to call it units then. Square units. Or make up a unit. Whatever unit you want. Centimeters, miles, feet, whatever works. And so that's basically all we're doing here for the most part. I do want to do 13 though. I'm going to leave you 12. So I look and I'm like, okay, bigger shape. I've got a trapezoid, a little different from a parallelogram. And then I look inside and I'm like, okay, so this cuts that off. So let's do the area of that triangle over here. So we got the area of this big guy. And we got minus the area of that guy in there. So let's see, trapezoid. Ooh, that's our base 1, base 2. So we'll pull some help back up here. So there's our trapezoid again. So let's see. Uh-oh. I got base 1.
Would it also be 12?
Let's see. I might have outdone myself on this one. I think we're going to go with the 8 plus 12 to get 20, even though that would be slightly short because, oh, I know what I was thinking, and it was not a good thought, but we're gonna roll with it. But I'm also learning this so I can see if I have to make an adjustment on the quiz that I made for tomorrow. So we're going to go, did I just do, oh my gosh, Hardy. Yep, I couldn't get through one whole lesson without doing that. I tried. I did try. Times my height divided by 2. Oh.
Wouldn't it actually be 20 as the middle part? Like you essentially have the rectangle with 2 triangles on each side.
Oh, okay. So let's try that. Let's bring this down. So if we bring this down, that's going to be 12. So then this would be 6. Oh, check this out. So it would, because, now see, I won't do this to you tomorrow because we didn't play with all the Pythagorean theorem stuff and things, but nicely played. Because here we could do 6 squared plus x squared equals 10 squared. And when we got all that out of the way, that would be 8. I like it. I will not put you through the ringer on that much of a mystery tomorrow. That was awesome. So let's get that situated. Love it. And then our triangle that we got left over here, even though we could have even played, I'm not even going to go there. I'm not going to make this more difficult than it needs to be. I'm good at that, but I don't want to be that good at that. So here's my base and my height. Again, the parentheses are helpful. Not as necessary this time. It'll still get it to the right spot. Yes, you may get some mysterious add and subtract sides, but yeah, you will not get mysterious Pythagorean theorem sides tomorrow. That was just an added bonus in here with everything that we were doing. All right, last portion. Let me do a little fast forward in here. So we got good old Jerome here. He's building a brick wall. He starts with 40 bricks and adds 12 bricks each hour. Uh-oh, linear or exponential? Quick rewind. Okay. Typically, if we're adding or subtracting a piece as we go along, it's going to be linear because it's that same amount each time that we're climbing, kind of like slope does. If it starts growing exponentially, okay, where we get this consistent multiplication part, but it's not just multiplication, it's an exponent that we're doing. So some of these I'm like, okay, if I were to make an equation out of this, and we did some of this in the practice, whatever you start with, that's not changing. That's kind of like we'd set our y-intercept portion. And if you see the words like each or per or something like that, that's the variable part. That's the variable part that's going to go with your x. So when I stop and I look at that, I go, okay, so at hour 0, when I'm just starting, if I plug in 0 for x, I get 40 out. That's what I started with. Okay, that makes sense. Now I can also plug in any amount of time that Jerome's been laying these bricks and know how many bricks are into the wall at that particular time, whether it's 2 or 10 or whatever it happens to be. But I also, if I'm not sure at this point, we probably are at this point, knowing what this is going to look like, but we can use pictures. If I graph something and I know what's going to happen, oh, there it goes. That looks like a line. To me, okay, if it's exponential, it's going to be more of a curve like we saw before. So some of these, if we can get an equation or if we have an equation, we can even punch them into the calculator to see if it's linear or if it's exponential, but that just kind of depends. That looks like a line. I'm not even going to talk about that. When you get to some of these other ones, though, again, if your notes help you enough to see, that's cool. But if not, you can always look. Whoop, if I hit graph, I can look at the picture. That's definitely not linear. Okay. Exponential. Let's see here. What else looks like it could cause problems?
The percentage.
Okay, let's
Number 18.
let's chat. Let's chat on a couple of these. Jen bought a new car for $32,000. The value of the car decreases by 14% annually. Okay, so I can tell you a couple of things about this, but let's do visual first. On this one, we did a couple of the application problems like this when we were doing the practice. So we put the 1 in there to hold the value of the car. What's decrease mean? Do I go up or down? Minus. And we know percentages are point. So that's what the equation would look like. But I'm going to show you something else with that that might be a little bit easier to remember than all that. And I think I'm going to have to do zoom. Which zoom do I want? Zoom fit. That sounds like a good one. Come on. And I'm looking, that doesn't look linear. That looks like it's curving. So when you typically get to the percentage problems are, oh, that's right, I got that video to show, are going to be exponential problems because they're either going to make it go, or they're going, like in this case with our car keeps going down and down until it's a rust bucket and being put in the junkyard. So kind of, let me keep this on the screen. So compare that to this one. Michael's salary at work is $54,000. Each year he'll receive a $3,000 raise. So there's that each word again. So if I wanted to make an equation, I'd be like, okay, he gets the 54, but each year he gets 3,000 more. So if I draw it just like that, I probably know that it's linear already. But if I wanted to be sure, I could take a peek, maybe. Here we go. Oh, maybe. Line, where are you? Oh, dear.
Maybe you need to zoom.
Maybe we'll do zoom out, because zoom fit is, oh, my calculator said, It's thinking still. Calculator, you're overthinking. Okay, we're going to turn you off for a minute because you're overthinking. You're going to have a... Come on. Okay. Let's come back here. Let's zoom again. Okay, let's zoom out. Hey, that worked good. Straight as an arrow. Linear. Okay. So this is basically what you're going to be looking at tomorrow as far as quizzy stuff goes. But again, you'll have